my name is Andy, and I want to talk about lessons learned from running Rails applications on on-premise infrastructure. So I think before we get into the technical details, I want to first establish a bit of context so you know what we're talking about. So as Dimitar already told, I work for a company called Simplificator, and we build custom software for all kinds of businesses. And in this case, our customer is Docker team. They are experts for digital archives, which means they can help you sort out digital information or even bring it into a digital form and then safely store it away in a long-term archive. For that, they have an in-house department which helps you with that, but they also developed custom software to help with all these processes, and we at Simplificate to support them with the custom software. You can also get that software on your own infrastructure if you want. This is what I will call on-premise going forward in this talk. And I think it was late 2020 when they approached us and said, hey, actually, it's kind of hard to get the software running on this on-premise infrastructure. And couldn't we somehow simplify that? And I remember going into that meeting, was like, yeah, maybe just write a couple of deploy scripts and then the whole job is done. And then going into that meeting, or after that meeting rather, I realized, okay, there's a lot of things we can optimize during our development process, and today with a special focus on the Rails apps, which helps their on-premise team to make the whole deployment and actually operating these applications on that infrastructure much smoother. This will be a bit of a guidance for today. So where do we want to run our Rails applications? So first and foremost, it should work on both Windows and Ubuntu server. Then we have 3 different database systems we would like to support. We have MySQL, the infamous Microsoft SQL server, and Postgres. And as an added bonus, there are a couple of servers where the Docker team software runs, which are completely offline, so no internet access, and we somehow should also support that. So let's get started. Let's talk about supporting different database systems from your Rails application. And like looking back at all of this wasn't actually a whole lot of trouble to implement. Because if you're using Rails, you're getting Active Record, and Active Record does most of the talking to the database for you. And it does so with the help of different adapters. So as you can see on screen, this is a part of our gem file in one of the applications. And for each database system we want to support, we added a different group with the corresponding gem for the adapter. And now when we want to set up the Rails application, let's say here for Postgres, then we can simply say, hey, if we want to run on Postgres, we don't need the gem for the Microsoft SQL server, and we don't need the MySQL one, and then we run bundle install, and we'll only get the Postgres gem. And then you set up your database YAML saying, please use Postgres. This is all to that. Of course, there are differences between different database systems, and we actually ran into a few of them, and here are only, let's say, a few highlights. So what we first noted is if you run Rails against MySQL, it always wants to write a char set information into your schema RB. And this kind of forced us to primarily develop against MySQL, because Postgres and Microsoft SQL Server don't need that, but they also ignore it if it's in your schema RB. We once had a very interesting incident. There is for some reason, there was like a lot of text in the database, and we found out that if you have a long text column on Postgres, it's 4 times smaller than MySQL. You probably will never hit that. It was still a very interesting afternoon of chasing a bug. And we also introduced the JSON column at some point. And if you ever work with JSON in Postgres, you know this is a lot of fun. It works very well. And you can actually get, I wouldn't say similar behavior, but you can instruct Microsoft SQL Server to do a kind of a type conversion for you between the text column you will have in your Microsoft SQL Server database and the pseudo JSON that your Rails application will then see. A common theme throughout this talk, I can already announce, is continuous integration is very important if you do a project like this. So we settle with Azure pipelines because, spoiler alert, we will also be running Rails pipelines on Windows, and we thought, the company who probably knows how to run Windows runners, it hopefully is Microsoft. And on the right-hand side, you can see parts of our YAML definition. What we essentially do is for each database system, but also for each version we want to support, there's a separate job, which leads to the image on the left-hand side. If you look closely, you can see, and I talked a few times about MySQL already, and it's not mentioned anymore on the left-hand side. This is because we dropped support earlier this year for MySQL to keep things a bit easier. So to quickly recap, our lessons learned here is organizing the different database adapters in different groups in your gem file worked very well. And continuous integration helps us having confidence that all the changes we do will actually work. So where are we at? Supporting different database systems is done. So let's move on to the next piece, which is supporting different operating systems. So let's go ahead and say, well, I mean, regardless if you run Windows or Linux, like your Ruby code will mostly look the same. I say mostly because in our code base, there are sometimes if statements saying, hey, if you are on Windows, do it a bit different, and if you're on Linux, do it a bit different again. But I would say, very rough estimation, like 99% of the code, the Ruby code that we write is the same. Now, if we first thought, okay, how do we install Ruby on Windows? I mean, I would say at Simplificator, we primarily use Linux, and so Windows is also a bit of a new area for us. And so we thought, okay, well, we only really need one Ruby version at a time on a server, but we also found out there's this tool called Euro Unleash Ruby, which would allow you to switch between different Ruby versions on a Windows installation, kind of similar as you might know from RBN for ASDF, whatever you use to manage your Ruby versions on your system. If you want to get Ruby for Windows, you can get it from rubyinstaller.org, and you will stumble upon this quote about this minimal system 2, which self-described is a bunch of tools and libraries which help you building and installing and ultimately running Windows software. And you might be wondering, okay, why would I need that? Because it's quite large. I think it's like close to a gigabyte. And it's because you might be aware that Ruby is written in C, and you can also write gems with C code. Here's an example. I installed Puma, and Puma has C code in it, and during the gem installation, when Ruby detects that, it will tell you building native extensions, which is just another word for, hey, I'm compiling a bunch of C code for you. And on a Linux server, you usually have GCC available. And on Windows, with the Ruby installer, as mentioned, you get this minimal system 2, which ships all the required build tools for you to also allow compiling the C code. As always, there's an exception to the rule. Here I install Nokogiri, and if you look on the second line, you might know the -linux.gem at the end. So Nokogiri also has a lot of C code, but they chose to pre-compile that C code for us, so we don't need to waste time compiling C code on our machines. What that means for a gem maintainer is for each platform, so Windows, Linux, Mac, and also for each CPU architecture, you need to release a different gem version. And it gets even further. For each Ruby version you want to support with that gem, you need a different file. So, I mean, for Nokogiri, you have 3.0 until 3.3 at the moment. So, where am I going with this? We went from Ruby installation to like some obscure pre-compiled gem. So, what we observed is on Windows, there tend to be a lot more of these pre-compiled gems. And so usually for us, it takes longer until we can go to the next Ruby version, because the gem maintainer first needs to release a new Ruby version containing this precompiled file for the next Ruby version. I can say as of today, we're still running Ruby 3.2. We're waiting for one gem to issue a new release, but then we can also finally move on to Ruby 3.3. Again, pipeline, very important to test the changes. So I have the same screenshot from before, but now we have 2 additional jobs on top, which run tests against Postgres and Microsoft SQL Server. We only run 1 job per database system on Windows, specifically to save time. Because if you look at the times, I mean, on Linux, we're on 3-4 minutes, sometimes 5. And, well, on Windows, we're starting at 11. And sometimes it goes up to 15 minutes, which is quite a long feedback loop. Why is that so? So one thing is on Azure DevOps, where we are running our pipelines, they only have a few Ruby versions pre-installed. So if we need a different one, then we have to install Ruby ourselves, and this already takes 4 or 5 minutes sometimes. And they also only have a couple of databases pre-installed. So Postgres is already there, so that's why the job is a bit faster. On each CI run, we actually need to install an entire Microsoft SQL Server, which also takes 3-4 minutes. And this is why we have this very long CI times on Windows. So I think the lessons learned for us here is, once we actually started optimizing the Ruby code for Windows, let's say, it did mostly look the same across from a couple of if statements, as I mentioned earlier. These precompiled gems can delay a Ruby upgrade. Once again, continuous integration helps spotting all the differences between the different operating systems. And the Windows build could be slow. As mentioned, we currently have Azure DevOps. I assume if you have something else, it could be faster. So we usually keep just a virtual machine around with Windows. So in case there is something broken on Windows, then we don't have like a 15-minute feedback loop, but it goes a bit faster. So we have 2 out of 3, or 4 rather, because there's a 4th point, which I didn't mention so far. So we support different database systems, and we support different operating systems. And now we're moving on to the offline installation. So if you think about this, what does that mean? You want to be able to install a software offline. And for us, it means that we need to ship a package which contains everything that is needed to run a Rails application. Now, for a lot of other languages, this is quite easy. I don't know, for Java, you compile Java code, you get out a bunch of jar files, and then you need the Java runtime, and this thing works. It gets even simpler if you have something like Go, or Crystal, Rust, C++, whatnot. You compile the piece, and then you have a single executable, which can be run. And for Ruby, there's not really a compilation or any pre-processing. Well, let's say there's nothing really you can do on your machine to make the piece, let's say, smaller. So you need to ship Ruby, you need all the gems, and you need all the code. And in case of Rails, you also need all your assets. Dimitra already told I enjoy Docker, and this is true. So, of course, we also looked into, could we use Docker to build our package with the Rails application? And I originally had a couple of slides in here explaining why we didn't feel like a good solution, but then I thought, well, you're Rubyists and you probably don't want to talk about Windows that much. So I give you the too long didn't read version of that. So there's 2 things you can do in Windows in regards to containers. One is you can run Linux containers, which require the WSL, the Windows subsystem for Linux, which you can imagine as a very well-integrated virtual machine in your Windows installation. And don't get me wrong, I personally use the WSL at home, and it's a really nice thing to use for development. But if you, let's say, imagine a professional setting, if you have a Windows server where you need to install a Linux virtual machine in order to run a bunch of Linux containers, for us it didn't feel like this makes a lot of sense. You could have just provided us with a Linux server up ahead and just remove one layer of abstraction. You can also run Windows Docker containers, and there we saw 2 issues here. One is that the image sizes get really large. Really large, I mean like at the start, I think at 4 gigabytes or so. And you also have very limited compatibility between different operating system versions. I mean, on Linux, you go ahead. I mean, you have, I don't know, a Debian maybe, and then you easily boot up, I don't know, a CentOS-based Docker image, no worries, right? And on Windows Server, this is kind of hard to do. You cannot run really a 2019 based image on 2022 unless you activate a bunch of other stuff. So too long didn't feel like a good solution at the time. So what we settled instead is we actually diverge paths. So for Linux, we ship Docker containers because it's a cool thing and it was super easy to do for us. And for Windows, we ship a zip file. So the zip file contains the Ruby version that the app should currently run. It contains all the Ruby code. It contains all the assets pre-compiled, and we also made sure to remove any references to JavaScript at runtime, so you don't need to install, for example, Node.js. And then we found this very nice bundle command, which allows you to download all the gems referenced in your gemfile.log, and it puts that into the vendor cache folder. And so, as mentioned, we have everything in that zip file. The problem is the zip file doesn't run, right? It's a zip file. I come back later why we settled on that solution, but for now, we wrote a PowerShell script. PowerShell is a shell language for Windows, let's say. You can also use it on Linux if you want. What the PowerShell script essentially does is it extracts the zip, installs Ruby and all the gems, set up the configuration that we need. It runs Rails migrations, right? And then also requires the Windows services, for example, to run the Puma web server or some background jobs thingy. And this doesn't require any internet connection to do so because everything is in the mentioned zip file. This originally started as a solution for our Rails apps exclusively, but nowadays there's several third-party dependencies that this PowerShell piece can install, and it's no longer a PowerShell script alone, it's actually a collection of scripts at this point. And again, in order that we know that these pieces work, we have CI jobs which tests the PowerShell scripts. And there we also do like a very little smoke test at the end. I mean, for Rails, we just query the root path and ask, hey, are you there? So we know that the software will actually run once extracted out of its zip package. So why PowerShell? Our favorite tool at Docker team right now is actually Ansible. The problem is Ansible does not work on Windows, so you can manage Windows servers, but you cannot invoke Ansible on a Windows machine unless you have WSL. And we needed something that doesn't require you to bring like a notebook to the customer in order to install it, so Ansible was ruled out. And we knew that the on-premise team at Docker team, which takes care of installing and operating all these installations, they are very proficient with PowerShell. So this not only allows them to read what actually happens during deployment, but they also can contribute back and improve and extend this collection of scripts. We also kind of wanted to avoid introducing additional technologies. So, or let's say, at least I mean, this was 2021. There are cool things out there, but nothing really stuck out where we were able to say, okay, this is something that is very low effort to implement. And if you have a cool idea here, I'm happy to talk about that. One thing I stumbled upon during research for this talk is this project called Okran by Largo. And it promises to turn Ruby projects into single executable files on Windows. I did not have the chance yet to check it out, but it would make our lives a lot easier, I assume, because then we could replace the zip file with an actual executable file. So to recap our solution, as mentioned, we have the zip file. It contains everything that is needed to run the Rails app. We have a PowerShell script, which helps then actually turning that zip file into a runnable thing. And we also have, once again, continuous integration on Azure DevOps for confidence in our deployment scripts. So we crossed off all the points that I originally mentioned, which were coming out of that customer meeting. And let's say over the time, as mentioned, this was end of 2020, early 2021. We're 3 years ahead. There's like a hidden fourth point which kind of came up, and also where the on-premise installation also play a major part in it, which is the topic of releases. So let me explain how we usually do that at Simplificator. If we have a feature request for a software that we host, then we create a feature branch, we code it out, add a bunch of tests, push it to GitHub most of the time, create a pull request so somebody can review the code. Most of the time, we also then, in parallel, deploy it to a test server so the customer can have a look and see if it's the thing that he imagined that it should be. And once everything is good, code review is good, customer feedback is good, we merge a pull request, and then the commit on the main branch gets automatically shipped to production. So if you have on-premise installations, this gets rather difficult. So first of all, we might not have access to those systems from a pipeline. I already mentioned there are servers which have no internet access at all, but I mean, I can also imagine that a lot of customers wouldn't be happy if we connect to their systems from somewhere. There are also sometimes certain policies in place which takes time until you're actually able to put a release into production. One example I have here is a customer once said, well, if there's downtime associated with your release, then you need to announce that a week ahead. Our PowerShell script is currently not able to deploy with zero downtime, so there's like a downtime of like 5 to 10 minutes. But you can imagine they wouldn't be happy if we deploy multiple times a day and then you have like downtime of 5 to 10 minutes each time. So we had to settle on a compromise, which currently is that we do regular releases for the software. And those releases we ship very soon to the cloud offering that Docker Team also has. And on-premise customers right now currently get 1 update a year, sometimes more, which is the so-called annual release. Another piece came up, I would say, which is a bit of the topic of semantic versioning. So since we know there's this one release a year that we want to ship to the on-premise customers, this is usually also a major release. A major release from our point of view is if we break functionality that the customer sees, because there are mostly user-facing applications. I mean, internally, we restructure and refactor code all the time. So let's say the internal API changes, but from the outside, it still looks the same. And another thing that we started to do just to avoid, or not to avoid, but rather keep the time short in order to deploy upgrades, is that when we want to break something, we first announce it that we're going to break it, and then in the next major release, which is usually the next annual release, we then, well, remove the original thing or rework or break whatever we announced that we're going to break. Let me say this requires a bit of planning ahead. So this is an example of something I implemented. So in July 2021, we implemented a replacement feature for something that was already in the application. And I would say the replacement feature we implemented was like for 95% of the use cases, it was much better than before. But we intentionally removed 5% of the original feature because we felt it was no longer needed. So we implemented that and saw, okay, we will break things. So we put the new feature behind the feature flag and said, hey, the old one is deprecated. Please activate the feature flag and use the new piece. This change got then shipped in April 2022 to the on-premise customers because the next annual release, so the annual release for 2021 was done, so next year. And then we kept the code around for a while. Until January 2023, where we then finally moved the original feature from the code base, and this then got shipped in May of 2023. So you see it's almost 2 years, and that's what I meant with requires a bit of planning ahead. Well, a bit is maybe, no, a bit more. So to recap this section, so continuous deployment to on-premise infrastructure, or if you offer on-premise, if you offer that your software runs on-premise, this is likely not possible. If you can do that, please do so. It makes life a lot easier. You kind of have to find like a regular update cycle that works for you, your team, and your customers. As mentioned at Docker team, we currently have like this annual or this yearly release cycle, or major release cycle rather. But I mean, it could see, depending on resources, that this could be 6 months or even 3 months, something like this. And again, if you want to break things in between major releases, is also a decision you can take. As mentioned, for us, I would say it works, not immediately breaking stuff, simply to support the on-premise team not having a very stressful time trying to fix all these on-site installations. But I mean, usually a major release breaks things. This is the whole purpose, right? So I'm at the end of the presentation. I also see I only took 26 minutes, so I don't take any time off your lunch. Thank you very much for listening. Thank you very much, Helvetic Ruby, for having me. If you want to get in touch, here are a bunch of social and the QR codes to our website. And once again, thank you very much. Enjoy the rest of Helvetic Ruby and Gute.